The last part of Mod 5 deals with the quadratic formula. The quadratic formula is a tool that can be used to solve any quadratic equation. Remember that the general form for a quadratic equation is ax squared plus bx plus c equals 0. You must have the quadratic formula memorized. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. On example 6, we want to solve the equation by using the quadratic formula. Our answers are to be written in exact form. On our first example of 9x squared minus x minus 2, remember that a equals 9, b equals negative 1, and c equals negative 2. Putting all of this into the quadratic formula, we would have x equals, the opposite of our b will become positive 1, plus or minus the square root of negative 1 that we are squaring, minus 4 times 9 times negative 2. All of this needs to be inside the square root. In the denominator, you will be doing 2 times the a, which is 9. If we work that arithmetic, we will have 1 plus or minus. In the square root, you will have 1 plus 4 times 9 is 36 times negative 2 gives me positive 72. All of that over 18. This gives us 1 plus or minus the square root of 73 over 18. Check your square root. Does the square root of 73 simplify? It does not. So that is your answer, and you need to leave it in this form. Do not put it in your calculator, leave it alone. To write it as separate answers in ALEKS, you would write 1 plus the square root of 73 over 18, or the second answer is 1 minus the square root of 73 over 18. On example B, we have 6x squared minus 3x minus 1, giving us a of 6, b of negative 3, c of negative 1. Putting everything into the formula, we will have x equals, the opposite of our b will be positive 3, plus or minus the square root of negative 3, which we are squaring, minus 4 times 6 times negative 1, our a and c, all over 2 times our a of 6. Doing our arithmetic inside our square root, we will have 3 plus or minus the square root of 9. It will become positive because we have 2 negatives, and that's going to give us a positive result. 4 times 6 times 1 is 24. All of that goes over 12. Inside the radical now, doing the addition, 9 plus 24 gives us 33. And then that goes over 12. The square root of 33 does not simplify, so that is your solution. On C, our equation of 2x squared plus 8x minus 1 gives us an a of 2, a b of 8, and a c of negative 1. Putting everything into the formula, we will have x equals, opposite of b will be negative 8, plus or minus, inside our square root, we will have 8 squared minus 4 times the a of 2 times the c of negative 1, everything over 2 times a of 2. Inside our square root, we will get plus or minus 64 plus 8, all over 2 times 2 is 4. This now gives us negative 8 plus or minus the square root of 72 over 4. We talked about the square root of 72 in class. The square root of 72 is the square root of 36 times 2, which becomes 6 radical 2. So our fraction now becomes negative 8 plus or minus 6 square root of 2 over a 4. If you look at all the numbers that are not in radicals, they are all even and all divide by 2. We must do this simplification if we can. Divide every term by 2, you will have negative 4 plus or minus 3 square root of 2 over 2. That is your final answer. The discriminant is the part of the quadratic formula that is inside the radical. This tells us how many real solutions there are to a quadratic equation. When we use the discriminant, we find b squared minus 4ac. Notice we are not using the square root symbol. We only find the inside of that square root symbol. You have 3 possible cases for this. If you do b squared minus 4ac and you get a number that's greater than 0 or positive, there are 2 real solutions to the quadratic equation. If you do b squared minus 4ac and you get an exact 0, it equals 0, then there is 1 solution to the equation. If b squared minus 4ac is less than 0 or negative, there are no real solutions to the equation. On example 7, we are going to find the value of the discriminant, and then from that, the number of solutions to our equation. On A, when we are finding the value of this discriminant, our b is negative 7. So we are going to do negative 7 squared minus 4 times our a, which is 5, times our c, which is 1. If we do this arithmetic, we will get 49 minus 20. This gives us 29. So the value of our discriminant is the 29. That's the answer to the first question. The second question says, find the number of solutions to the equation. Because this 29 is positive, then we know that there are 2 real solutions. On example B, when we have the equation of 3x squared minus 9x plus 2, doing our discriminant, we would do negative 9 squared minus 4 times the a of 3 times the c of 2. Negative 9 squared is 81 minus 4 times 3 is 12 times 2 is 24. To do that subtraction, you get 57. So the value of the discriminant is 57. Since it's positive, we have 2 real solutions. On example C, b squared is going to be 8 squared minus 4 times a of negative 9 times c of negative 4. 8 squared is 64. Negative 4 times negative 9 is positive 36 times negative 4 gives me negative 144. Do that subtraction, you get negative 80. The value of the discriminant is negative 80. Because it is negative, there are no real solutions. On example D of 9x squared minus 6x plus 1, b negative 6 squared minus 4 times a is 9 times c is 1 will give us 36 minus 36. So the value of our discriminant is 0. When this happens, we have one real solution.